to talk about functions, section 2.1. And a function f is a rule that assigns to each element x in the set A exactly one element called f of x in a set B. The domain of f is the set A, and the range is a set of all possible values of f of x. Okay, so essentially we have two sets. There's A, and then there's another set B. A is called the domain. B is actually called the codomain, but don't worry about that. And then you have these elements in X that live in here, and the function takes each element, associates each element in X with an element f of x over here. So each element gets associated with elements over here. Now the set of all elements over here that are that there's some element here that's associated with it, that set over here is the range. Okay, so the range is not necessarily equal to B. It could be a subset of B that's not equal to B. Well, actually the range has to be a subset of B, but it doesn't necessarily have to be equal to B. Okay, so that's the idea right there. There are 4 different ways to describe a function. You can say verbally. So for example, if I say take x, cube it, cube x, then divide by 2 or something. That could be a description. Another form is algebraic with a formula. And this same function would be, you could describe it like, okay, so you're cubing x, and then you're dividing by 2, right? So it'd be that. You can do it visually with a graph with the x and the y coordinates. So the x usually represents the domain, the y-axis represents elements in the, it represents the codomain or the range. And so then your function would look something like this, okay, graphically. And then numerically, where you've got like a table, and you can like plug in different values. So 0 gives you 0, 1 gives you 1/2, -1 gives you -1/2, so on, okay? Now, the thing about functions is what you can't have is you can't have an element in the domain associated with 2 elements in the range, or with more than one element in the range. Okay, so if you have that, then it's not a function. So each element here has to be associated with exactly 1. You can, however, have 2 elements here be associated with the same element over here. That can happen. Okay, and then finally, we have this last topic right here, which comes up a little bit in this section. It's important for calculus. So we have the net change from A to B. That's f of B minus f of A. And then you have the average rate of change, which is f of B minus f of A over B minus A. And this is another form for the average rate of change. Okay, so those 2 things like that. Okay, so let's get into some exercises. These are the concepts. Let's get into the exercises of those. So number 1, if f of x is x cubed plus 1, then give the following. Okay, so the value of f at x equals 1 is, okay, so the notation for this would be you're putting a -1 in here. Okay, and then, so basically you're trying to find f of -1. And in this expression, this x has been replaced with a -1. So this x is like, hey, replace me also. What's up with that? And so you just have to, do what I don't want to be replaced with the same thing. Okay, and then, so then if you evaluate that, you get 0. Okay, and then value of x is at 3. That would be f of 3. And so you're looking at f of 3. And that x got replaced with the 3 this time. So that means this x gets replaced with a 3 also. And I like to put parentheses around whatever I'm replacing. So that's 27 plus 1, or 28. Okay, so that's going to be 28. Okay, and then that last thing that we talked about, the net change. Remember from the previous page, the net change was f of b minus f of a. From this first point to this first x value to the second value, which means that this is the second. This is like our b right here. This is like our a. So f of b, that would be this 3 goes here, and minus f of -1. Okay, so this right here is like our f of b, and this is like our minus f of a. Okay, from the formula, that's the net change right there. Okay, so that's going to be this value minus that value. So just because f of 3 is 28. So, and then f of -1 is 0. So just 28 would be the answer there. Okay, moving along. Number 2, for a function h, the set of all possible values of all possible inputs. Okay, so here, this is h, is called the domain of h. And the set of all outputs is called the range. Okay, so that's just another way of describing what we went through on the first page. If there's any questions, just speak up, please, at any point. Okay, that's great. Or write something in the chat. I'm watching the chat also. Okay, so number 3, which of the following functions have 5 in their domain? So remember, the domain is the x values, or the values that you can plug into the function. So I can put a 5 in here. If I put a 5 in here, I get 5 minus, I get the square root of -5. And for the functions that we're dealing with, there have to be real values that you get. So that means that this one, the answer was no for that one. And then, but here, right here, you can plug a 5 into here. You just get 0 in the numerator, which makes it be 0. Okay. So that one is okay. So so the first and the last ones have 5 in their domain. Okay, for part B, for the functions that do have 5 in, find the value of the function at 5. So here, they want us to calculate f of 5. So that x already replaces a 5, so we'll replace these x's with 5s in parentheses. So that's 25 minus 15, which is 10. Okay, so that answer is 10. G of 5, we already went through this one. It's this one here. That's kind of strange that they would change the order, but that's going to be 0. And then this one right here, that's undefined. So we already discussed that was undefined. So instructions say to write undefined in the box there. Okay, because if you try to calculate it, then you get that, which is not allowed. No complex non-real numbers allowed. Okay, so that's number 3. Moving along to number 4. A function is given algebraically by the formula x minus 4 squared plus 3. Okay, so the verbal, we're going to do the verbal of this function, and it's kind of like a bedtime story. Okay, so we'd start out with, once upon a time there was an x. Okay, so here you have x. And the first thing is you subtract 4, right? That's the first thing. Then the second thing is after it's subtracted 4, then it's squared. Okay, so square the result. Okay, and then after that, you add 3 and add 3. Okay, and that would be so the squaring the result's the second, and then the last thing would be add 3. Okay, so it's important that you start with the x, and then you work your way out from there. And because those are the first things that you're going to do. As you work your way out, that's the order of how the operations go. Okay, let's look at the next part. Numerical would be with a table like that. So as you can see, if you put a 0 in, you get, they filled in the first one for us. You get 0 minus 4. It's just plugging the 0 into this expression, which that's going to be 16 plus 3, that's 19. Okay. If you plug a 2 in, you get, this is 2 minus 4, which is negative 2. Square that's going to be 4, and that's going to be a 7. If you plug a 4 in, then you're looking at 4 minus 4, so that's replacing this with a 4. And that's going to just be 3. And if you plug a 6 in, then you're going to get, again, a 4 plus, you're going to get 7 again. Okay, so notice that you can have 2 values that are the same over here. That's okay. What you can't have is 2 values over here that are the same. Okay, so this is perfectly fine. Okay, number 5 is kind of along those lines, where you're supposed to, let's see, a function f is a rule that assigns to each element x in a set A exactly 1 element in the set B. Okay, so each of these values here is assigned exactly 1 value, even though this 7 over here is associated with 2 values from there. That's fine. What you can't have is 2 x values being associated with different y values. That doesn't work. Okay, here all the x values are different, so that's fine. So it's the number 1 is a function. Number 2 is not a function. Okay, so not a function. So if you can kind of think about, let's say, for example, a function could be the high temperature of the day, okay? Or better yet, let's use this example. A function could be, at the end of the course, your letter grade that each student received. Okay, so you can have 2 students receiving the same letter grade, right? You can have 2 students getting an A, or you can have more than 2 students getting an A. Or you could have no students getting an A, but probably not going to happen. But you can't have 1 student getting 2 different grades, okay? So you can't have a student getting an A and simultaneously getting a C in the same class. Okay, in different classes, of course, you could, but in the same class, this is what we're talking about. Okay. So that's kind of an example of that. Okay, number 6, yes or no? Let f be a function. Is it possible that f of 5 is 1 and f of 6 is also 1? That one is possible. Okay, because you can have, these are 2 different values. The 5 and the 6 are 2 different values. But here the 5s are the same, so that can't happen. So the answer here is no. And this is the first. This is a function assigns each value of x in is summing to exactly 1 value f of x. The other answers don't make sense. A function. Okay, number 7, express the rule, square, then add 3. Okay, so you start with an x, and you square it, so that means you're going to get x squared. Okay, now it'll be this part. And then you're going to add 3 to the result, so plus 3. And that appears to be it. So, okay, so again, start with x and do this operation to x. So you end up with x squared. And then add 3 to the result. Okay, so let me just contrast that with if it said, for example, if it said add 3, then square. So what happened here is you would add 3 to that, and then you'd square the result. See, so here you get something different than this. This is different than that. Okay. And not all functions can be described this way. Like if you were to expand this out and have, you would have 6x, so this is the same as that. So if we didn't know that we could rewrite this like this, then it would be really hard to use it, do a verbal expression for x, because there's 2 x's here, okay? There's x appears in 2 different spots in the function. So when that's the case, it's kind of hard to do a verbal explanation. Okay, let's look at number 8. Evaluate the function at the indicated values. Okay, so k of 0, 5, and so on. Okay, so let's start with k of 0. Here's k. So the x, this x here replaced with a 0, so we're going to place these 2 x's with zeros. And of course, those are all zeros, so that answer is going to be 6. And then k of 5. So that x star replaces a 5, so they're going to replace these 2 x's with 5s. And I'm going to put parentheses around it. This is really important to recognize that this means you square the x first and then square whatever value is first and then multiply by negative. So this is automatically going to be negative or possibly 0. So that's negative 44. K of negative 5. Now here's where it's important to put parentheses around, replace the x with parentheses, because then we know that the square comes up here. So this is negative 5 quantity squared is positive 25, but then you have a negative sign there. Here we have negative 5 times negative 5, so that's plus 25. So that's going to be 6. Okay, now k of the square root of 5. So here we're going to put the square root of 5 inside, like that. Okay, this becomes, the square root of 5 squared is positive 5, but then you have this negative sign out here, so that's negative 5, minus 5 root 5, plus 6. Okay, so that becomes, okay, so you got negative 5 plus 6, that's 1, minus 5 root 5. Okay, so 1 minus 5 times the square root of 5. Okay, now this next one, k of, let me do a different color because it looks like we're going to conflict with that one. Okay, so now here, this is a little bit more tricky. The students have a lot of trouble with this, or some students do. Probably none of you will, but okay, so anyways, here, in this expression, the x was replaced with a plus 5, not just an a, not just a 5, but an a plus 5. that means each of these x's gets replaced with a plus 5. Okay, now it's important to, if you have a binomial like this, squared, the correct way to look at it is this. Okay, and then use the FOIL method, unless you know the formula. Okay, so the first one's a squared, plus the outside is 5a, the inside is also 5a, so that's 10a, and then the last two is 25. Okay, so this is going to be a squared plus 10a plus 25. Okay, this one, negative 5 distributes, so negative 5a minus 25. Okay, so negative 5 times 5 is 25 plus 6. Okay, so distributing the negative, you get negative a squared minus 10a minus 25. Okay, minus 5a minus 25 plus 6. And let's see, a squared. Okay, these two combine to give you negative 15a. Those three combine to give you minus 44. Actually, it didn't say simplify, so actually, you know what? You could just put this in. That'll give it to you. But this also would probably work. Okay, and then this one right here, k of negative x. So x got replaced with a negative x. With it, well, this is kind of weird, but you have to just focus. You concentrate on this one and that. Okay, this x was replaced with a negative x, so that means that each of these x's has to also be replaced with a negative x with parentheses around it. Okay, so this one, when you square negative x, you get positive x squared. This one, the negatives cancel, and you get that. So negative x squared plus 5x plus 6. Okay, let's go with this last one. K of x squared. Here the x is replaced with an x squared. So again, just follow the instructions and replace these other x's with what this x was replaced with. X squared when you have a let me use a different letter. When you have a number that's raised, hold on. When you have a number and it's raised to an exponent, and then that expression is raised to another exponent, then you have this, b to the m times n. Okay, so here you have squared, so that's 2 times 2 is 4. So that's going to be x to the 4th. And then, of course, this is just minus 5x squared plus 6. Okay, number 9. This is called a piecewise defined function because there's these different pieces. There's 3 pieces here, and it's defined in different ways. So with this right here, what you need to do is look at this first to decide what you're going to do. Okay, so it's like if you're playing, let's say you're playing football, for example, and it's like, okay, if the other team, and you're on the defense, if the other team decides to pass the ball, then you do this. If the other team is going to run, then you do this. If the other team is going to, kick off the ball, then you do this one. Okay, then you do this. So you look, if this if they're going to run, then you do this. If they're going to pass, you do this. If they're going to kick it off, then you do this. Okay, so it's a different right, what you choose, the strategy that you choose here depends on this. The one that you choose here depends on that. Okay, so let's go. Okay, let's run down the first one. Okay, so -5 is here. Okay, so -5 is less than -2. Okay. So you're looking at the 8x, okay? But you're looking at this one. Okay, but that means you plug the -5 into there and you get -40. Okay, so that was a little bit confusing. Let me try to make the next one more clear. Okay, so here, -2 is in this middle one. So this one is in the middle one. So you plug it into this one. You plug it into the middle formula. And that's going to give you 2. 1 is also in here. So you plug it into the middle formula and get 5. Okay, 2 is also in here. Okay, so 2 is also in there. So you plug it into the middle one again and get 6. And then finally, 5 is greater than 2. So that means that this last one is in the last one. So you plug the 5 into here. Okay, so you plug a 5 into there. So that 5 goes into there because so 5 satisfies this, so you put it into here. Okay, so you get that answer there. Okay, let's look at number 10. Use the function f of x equals 2x squared plus 3 to evaluate and simplify the following. Okay, just follow this again. This x got replaced with x plus 2, so that x wants to also get replaced with x plus 2. Like that. I mean, it says simplify, so I can't. Otherwise, I would be tempted to just put this in there and see what happens. But again, this one, you think of this as x plus 2 times x plus 2. And in that case, it's going to be x squared plus 4x plus 4. Distributing the 2, you get that. And then combining the 8 and the 3, you get 11. Okay, and then the second part right here, it's f of x plus f of 2. So you already have an f of x, which is this. So this is going to be 2x squared plus 3. And then f of 2, you're plugging a 2 in for x. So that's 2 times 2 squared plus 3. So this is all 8, and that's 3, and so 8 and 3 and 3 is 14. Okay, great. Let's look at the second part, number 11. Find the net change in the value of the function from -2 to 5. Okay, so remember from the first page, that's going to be h of the second value minus h of the first value. Okay, so we're going to plug a 5 into here. Okay, so this t was replaced with a 5, so replace that t with a 5. This t is replaced with a -2, so replace that t with a -2. And then just kind of simplify it out. So that's just 25 plus 5, and this is 4 and 5. So, but then there's this negative sign, so we'll distribute that in. These 5s reduce, and you're left with 21 as the answer. Okay, number 12. Find f of a plus h, and the difference quotient for this function here. So first of all, f of a, so here this x was replaced with an a, so replace these x's with a's. So that's f of a. Okay, f of a plus h. Here, this x was replaced with an a plus h. So replace this x and that x each with a plus h's. Like that. And then simplify. So let's distribute the 3 in. And that'll be the second one. Okay, now, the third one, that's the fun one. It's this one right here. F of a plus h minus f of a all over h. This is called the difference quotient. It's a really important concept of calculus. F of a plus h we already know is this. F of a, we already know this, but we're subtracting though. And then h right there. Okay, this is kind of nasty, but what we're going to do is we're going to get common denominators. So this denominator is different from that one. So what we're going to do is we're going to take this first term, and we're going to multiply by this divided by itself, this denominator divided by itself, okay? Okay, and then we're going to take this term here and multiply it by this denominator divided by itself. Dang, and we're going to run out of space if we do this. Okay, so what happens is now is tricky. But now when this expands, the denominator of this is going to be the product of that and that. the denominator of this whole term is going to be the product of that and that. So they're going to have the same denominators, and that, it's a denominator of the numerator, that can go to the denominator as the numerator of the denominator. Okay, so unfortunately, I'm skipping a few steps right here. Now, what we're going to do is we're going to multiply this and this with each other. Okay, so it's this times this product here. Okay, 3a times a, that's 3a squared. And then 3a times -2, that's minus 6a. 3h times a is 3ha, and math is laughing at us now, look, ha. Okay, now this times this is minus 6h. Okay, that is just this piece right here. Now we also have this piece right here. 3a times a is, and they're all minuses, so we're going to keep track of that. So minus 3a squared, and now we have the minus and the 3a and the h, so minus 3ah. Minus 3a times 2, that's going to be plus 6a. Okay, now this and this are going to cancel. Okay, and then also, let's see what else. This and this are the same, or they're negative to each other. They're going to cancel. It looks like that and that also cancel. And we're just left with a negative 6h. Okay, so we're left with just a negative 6h. And so this h and that h reduce to 1. After all that happens. And so the answer is going to be -6 over this product here. Well, that was difficult. Okay, so number 14. Find the domain and range of this. Okay, so first of all, domain. The domain is a set of x values, and you can put anything in there, literally. Okay, so that's going to be negative infinity to infinity, because you can put anything into here. There's nothing, you can put any value of x in and you're fine. Okay, for the range though, the range is the value that you can get out of this. Now, one thing that's going to happen is that's always going to be greater than 0 always. Because even if you put a negative number in for x, when you square it, it's going to become positive. You can put a 0 in for x, and that will be 0. Okay, so if you take something that's greater than or equal to 0 and you add 2 to it, then you're also going to be, and that's always going to be greater than or equal to 2. So your range is going to be from 2 to infinity, including 2. Okay, now this one right here. The second one, I copied it down wrong. Fortunately, we don't have to deal with that, so forget that. Okay, just find the domain, okay? Now, you can factor the denominator. like that. And if you take the denominator and you set each of these equal to 0, you get -6 and 5. Okay, so the domain, there's a good thing for you guys. Whenever you think of, whenever a question asks you about the domain, then what you should do is think of the following things. First of all, you can't have any zeros in the denominator. No zeros in the denominator. And that's what we're dealing with right here. You can't have any zeros in the denominator. The other thing is greater than or equal to 0 in the square root sign. Okay, those are the two things. No zeros in the denominator, and you have to be greater than or equal to the square root sign, and in the square root, okay? Inside the square root. Since there's no square roots, everything else is fine. You can plug anything in. It doesn't, the numerator doesn't really matter. You can plug any value of x can go in the numerator. The only problem is if you plug in a -6 or a 5, you have to exclude those two values. So the way to exclude those is to do this. That excludes the -6, because these open parentheses means that this interval does not include -6. This interval also does not include -6. And then this interval also, these intervals don't include 5. And this interval doesn't include 5 either. Okay, so that would probably be the best way to write the answer. Maybe it's the only way to write the answer. Okay, so there's that. You can get this symbol by going to the set notation, or you can just type in the word union, and as soon as you hit the N, it should change to that. Okay, so now this problem right here is if I find the domain of this function. This one is the second one that I had. Okay, so this is a 4th root, so it's an even-powered root, which means that I have to have, this has to be greater than or equal to 0. Okay, so now if I factor this times this has to be greater than or equal to 0. Okay, and that can happen if both these are positive or if they're both negative. But if one is positive and the other is negative, then this is not going to work. So the way to analyze this would be, okay, so here we have 0, here we have 5. That's where these terms are equal to 0. This term is 0 when x is 0. This term is 0 when x is 5. Okay, so I've got those two values there. Okay, now, this is the number line. It represents the number line. Over here, you have values that are less than 0. If x is less than 0, then x is negative. And x minus 5 is also negative. Okay, now you have between 0 and 5. If x is between 0 and 5, then x is positive. But if you take a number between 0 and 5 and you subtract 5 from it, then you're going to be negative still. Over here, you're greater than 5. That's positive. That's also positive. Now, the product, which is what we're after, which is inside the square root sign. Positive here, because you're taking two negative numbers to multiply them together. It's positive here, because it's two positive. It's negative in the middle. Okay, so that means the middle is not part of the domain. And the domain is going to be from -infinity to 0. It's okay to have 0, because you can take the 4th root of 0. It's just 0. You have to exclude that. And you're going to union that with 5 to infinity, this interval here. Okay, so that's the answer to number 15.